Hello and welcome to the 19th episode of Stay Nerdy, my friends. In today's episode, I'm going to be talking to you about wormholes, cosmic strings, and black holes in that order. And the main reason I'm talking about this today is because I've noticed that in pop culture and in the television and whatnot, wormholes and black holes are sort of an interchangeable idea, and they're really not. So first, I'm going to talk to you guys about wormholes and how they work. For starters, wormholes, also known as white holes or Einstein-Rosen bridges, um, they're called Einstein-Rosen bridges because they were first theorized and proved to be possible by Albert Einstein and Nathan Rosen. Um, so here's how it works: you have two objects. You have Earth and Proxima Centauri, also known as V645 Cen, if you're a scientist, but just call it Proxima Centauri if you want to. This is, other than the Sun, the closest star to Earth, and it is approximately 4.2 light years away, which for most of you know, but for some of you don't, a light year is how far light can travel in a year, obviously. So that means that if we were able to travel at the speed of light, it would take us 4.2 years to get to Proxima Centauri. Sorry, I don't know why I keep doing that. Anyway, so here you go. So if you were to try to travel from Earth to Proxima Centauri, it would take 4.2 light years if you were able to go at the speed of light, which for this thought experiment, we say that we can. But that's still a really long time to get to Proxima Centauri. So if we're taught that the shortest distance between 2 points is a straight line, which is what I just showed you. It's 4.2 light years. However, a wormhole theorizes that the fabric of space is relative to where you are and how you behave in it. So, the theory of relativity states that there are some objects that can bend the fabric of space and time, and it's like this paper now. So, instead of Earth being here and Proxima Centauri being here, now they're just a short travel through a wormhole away, and that's what a wormhole is. It's that connecting point between this side of space and this side of space. See, that's how it looks, but then the wormhole itself it's sort of, basically think of it as a portal. That's the best way to explain it. So now instead of traveling there in 4.2 years like this, you're shooting right through the space-time, and you are getting there as just like basically in a flash. The main problem that I have with wormholes is that they haven't been proven to exist. I mean, the math is there, don't get me wrong, and it's really interesting, but no one has ever seen a wormhole in real life, and there's no proof that they actually exist. The only thing that we have any proof of is that the theory of relativity allows for such objects. That's what Einstein and Rosen did. They just worked out the math, and they showed that, yes, it is in fact possible for wormholes to exist. Because, like I said, the theory of relativity states that no matter where you are in space, everything, including space itself, behaves relative to how you are. That's the easiest way to explain relativity. There's also a lot of really complicated explanations, but that's the one I like the most. And it's the one that's easiest to understand. So, the problem with wormholes is a lot of people who are big, wormhole advocates say that the reason we haven't seen wormholes is because they collapse fast, and Einstein and Rosen showed this, because a wormhole is a really fragile point between these two sides of space, and it closes fast. It opens in a flash, and it closes in a flash, basically. And so if you were to go into a wormhole, like say that you were in a spaceship and you go into a wormhole just like you are right now, you would be stuck at the center of it in a singularity, just like a black hole. However, the difference between black holes and wormholes is that if you had a large amount of negatively charged matter, which is just exotic matter, anything that's not what we have, like this, my whiteboard is regular matter, my iPad is regular matter, everything in my room is regular matter. But there is such things like, dark energy, dark matter, antimatter, blah, 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 blah. All of that stuff is exotic matter. So if you were to find a large quantity of that, it's possible that when you go into the wormhole, it would be stable enough because of the interaction between the regular matter and the exotic matter that the wormhole itself would stay open long enough for you to get through it. And I mean, that's all cool and everything, but finding that much exotic matter, it's not like you can just run to the corner store and get exotic matter. I mean, it's rare, if even that. I mean, it's super rare. Well, for the most part. I'll do a whole nother episode on exotic matter. As a matter of fact, I have to make a second episode today, and I'll make that one about dark energy and dark matter versus antimatter. That'll be really good. So that's a wormhole. Next, I'm going to talk to you briefly about cosmic strings. This is somewhat less popular in physics, but it is still somewhat popular, so I feel the need to bring it up in this discussion. Basically, cosmic strings say that at the beginning of the universe, during the Big Bang, these strings were created. And so basically there are just these random strings floating out in space, and they're pretty widespread because they were there at the beginning of the universe. But what they say is that because these have so much energy and gravitational pull inside of them, if you were to go close, one theory in cosmic strings is that you sort of slingshot around them and travel faster than the speed of light. That's kind of weird, but not, in my opinion, it's impossible, but who cares? The other theory is that because these strings are moving, they're not just stationary, they move fairly fast, so it's said that the main theory into them is when you get close enough to their gravitational pull, you are now stuck in their gravitational pull, and you're moving as fast as you're moving and as fast as they're moving, which means that you're traveling close to the speed of light, or even faster in some cases, which, once again, the light speed is absolutely the speed limit imposed on the universe by Albert Einstein, and I have learned not to question Albert Einstein, so I personally don't believe in these theories in cosmic strings. I don't say that they don't exist, but yeah, I think that those theories are completely bonkers. Anyway, so black holes. Super fascinating. I've already talked to you guys briefly about them and sort of what happens when they come together. But basically what a black hole is, it's not what you see in popular culture where there's just a big moving ball of rah. No. If you were to look at it, it would look like a black sphere because it's a three-dimensional object. However, the black hole itself is just one inconceivably small object. So that's really interesting. Basically what would happen whereas with a wormhole, if you had enough exotic matter, you could theoretically travel through them. In a black hole, no matter what you are, if you go past the event horizon of the black hole, you will simultaneously be crushed into the tiniest, inconceivably small particle that you could possibly imagine, and you'd be ripped to shreds, and that's hard for people to understand, but it is what it is. So, that's what a black hole is. The other thing is, black holes have actually been proven to exist, and we've seen them. As a matter of fact, there are supermassive black holes at the center of our solar systems. I believe I've said that in one of my episodes, but in case you're a new person and you haven't seen my black hole collision episode, which I think only 20 people saw it, so who cares? That's what they believe causes our galaxies to create, because you can see there is a supermassive black hole at the center of our galaxy, not at our solar system. That would be trippy. So anyway, that's what a black hole is. In my next episode that I'm going to be recording right now and uploading right after I upload this one, I will talk to you guys about what dark matter and antimatter are, and I might talk a little bit more about black holes. Yeah. Okay, so share this video with everyone that you know. Subscribe to the channel. It's a good channel. We're only 8 subscribers away from our goal of 50 subscribers by the end of March. That would be super cool if we could do that. So, other than that, all I can think of is stay nerdy, my friends.